Construct a parabola when the distance between the focus and directrix is 50 mm. Also draw a tangent and a normal line to any point on the curve. So this is the question. In the question itself, they have mentioned that the type of curve we have to draw. So here the parabola curve we have to draw. So what are the data is given? They have mentioned as parabola, that is one data. Another data is the distance between the focus and directrix is 50 mm. So there are two data given. By using these two data, we have to draw parabolic curve. So given it is a parabola, if it is a parabola, eccentricity ratio is equal to 1. So eccentricity ratio equal to VF divided by AB. Here the total distance, that is A to F, directrix and focus, distance between focus and directrix distance given as 50 mm. So if it is eccentricity ratio equal to 1, the moving point, there is a point which is moving and ratio of 1 in between focus and directrix. If it's so, the moving point distance from focus will be 25 mm or the moving point distance from directrix will be 25 mm, so that eccentricity ratio equal to 1. So the following step-by-step procedure we have to follow for constructing the parabolic curve. So first we have to draw vertical line, that is a directrix line, name it as T and T dash. Then to this line, to this vertical line perpendicularly, we have to draw an horizontal line. This line is going to acting as a axis to the parabolic curve. Then on this axis line, we have to mark focus point. So before that, this vertical line, there is a directrix line and the axis lines are meeting. So the meeting point, give the name as A. Then here the distance between focus and directrix given as 50 mm. So A to F from A, that is on the axis line. From A for about 50 mm distance, mark a point and name it as F, that is a focus point. Once we have marked the focus point on the axis, then we have to mark vertex point. Vertex, that is a moving point. We have to mark this V point based on the given eccentricity ratio. In this problem, eccentricity ratio not given, but instead they have mentioned the type of curve. It is a parabola. If it is a parabola, eccentricity ratio is 1. So if it is 1, the moving point distance will be exactly midpoint of the focus and directrix. So here the distance between the directrix and the focus is 50 mm. So the moving point distance from directrix will be 25 mm. Similarly, the moving point distance from focus will be 25 mm. So by taking 25 mm distance from either focus or from directrix, you have to mark a point on the axis line, name it as P. From B, we have to draw a vertical line in such a way that a VF distance equal to VC line. So the vertical line, give the name as C to other end. One end is V. From vertex to the axis line, perpendicularly you have to draw another line. To the other end, name is C. The distance of VC, that is equal to VF. So here the VF distance is 25 mm. So for the same 25 mm from B, we have to draw a line, name it as VC. Then after drawing this VC line, from A, we have to draw a line passing through this end C. Then extend the line based on your convenient distance. Name it as AC line. Then from vertex on the axis line, we have to draw a number of vertical lines. This vertical line should be perpendicular to the axis and parallel to the directrix line. Then this vertical line meeting the axis line, give the name it as 1, 2, 3, 4, 5, 6, 7. Similarly, the line meeting the AC line, the name it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Likewise. Then if the point, the B point is moving in a eccentricity ratio of 1 means we have to track that moving point at various locations. So for that we have drawn this number of vertical lines. To those vertical lines we have given the numbering as 1 1 dash 2 2 dash 3 3 dash. Okay. So now we are going to track that moving point. So for that, using our compass, you have to measure the distance, this one. So this is 1 1 dash. Using our compass, measure the distance 1 2 1 dash as radius, F as center point, make a arc on the 1 1 dash line above the axis, then below the axis. Name it as P1, P1 dash to the arc. Okay, similarly, measure the distance 2 2 dash as radius in your compass. F as center point, make a arc on the 2 2 dash line above the axis, below the axis. Name it as P2, P2 dash. Then again, similarly, measure the distance 3 3 dash as radius. F as center point, make an arc on the 3 3 dash line above the axis, below the axis. So here the thing is that in which line you are taking measurement as radius, on those line only you have to go for arcing. That is one of the important things you have to remember here. Likewise, you have to continue. So for example, in this, they have continued to 10, 12 to 15. So for example, 15 arc they have continued. After drawing the sufficient arc, you have to draw curve passing through all the arc from vertex. Then you will be getting parabolic curve. Then you have to name it as a parabola. Now we have constructed the parabolic curve. After drawing the parabola, we have to draw normal line and tangent line at any point on the curve. That is another parameter we need to find out as per the questions. So for drawing this tangent line, normal line, what you have to do here, there is no condition. So on this curve, you mark a point somewhere. I'm marking here, name it as M. And you connect this M and F. You will be getting FM or MF line. To this MF line perpendicularly from F, you have to draw another line until meeting this directrix line. To the meeting point, give the name it as a T dash. From T dash, you have to draw a line passing through point M. Then extend the line. Name it as a T. Now this T dash line is acting as a tangent line to the parabola curve. Then to this T dash line, tangent line, perpendicularly through M, you have to draw another line passing through M, another line, name it as N dash. That is a normal line to the parabolic curve. Okay. So now we have completed. This is a parabolic curve, a tangent line, normal line. Then show the dimensions suitably wherever the dimensions are needed. You have to show the dimensions with dimension lines, proper arrow head. Then you have to give the explanation for all the notations. Suppose if we use any notations in the drawing, you have to give the explanation. T dash means directrix line, TT dash tangent line, N dash normal line, F means focus. What type of scale? Actual for the whatever the dimensions they have given for the same we have drawn. So scale is 1:1. The curve is a parabola. So at the bottom right answer you have to write all dimensions are in mm. That means the drawing is made up of by following mm unit. Okay.